Hi everyone, we're solving the lead code question for today, in which we have to return the largest almost missing integer. So let's see what missing integer means. Missing integer is an integer which is present in exactly one subarray of the array, and it appears in exactly one subarray and is the largest. So we have to return the largest missing integer or among all the missing integers, and minus one if nothing like that exists. So, to understand this question, let's say we have an array. Array can be anything, right? And let's say we have the value of k, which is the length of the window. So, let's say the size of array is n, right? And what happens? Like, what are my possible values of k? So, my possible value of k is k can be 1, k can be equal to the size of array, which is n, and k can be anything greater than 1 and anything less than n. So it can fall into three subcategories, right? If we solve this using sliding window. Now, this is my first case, this is my second case, and this is my third case. So let's break it down this way. What happens if, to this question, if my k is 1? If my k is 1, so every element in my array, which is this, um, is a potential candidate for missing integer, right? And we have to find the largest missing integer. And every candidate is like, each number let's say this is my every integer is a window in itself, is what I mean to say. So this window, then this window. So every element is a window. So how many missing integers can we have here? Anything with frequency 1 is a missing integer, right? So anything with frequency 1, global frequency 1, global frequency is 1. It means that it is not present in any of the other subarrays, and the max of it, and the max of it. So this will be my answer, right? If my k is 1. What happens if my k is n? I only have one possible window, which is the entire array. Now see, this thing about missing integer, it doesn't say that frequency of the number x should be 1. It just says that it should appear in exactly one subarray. So there is exactly one subarray. So when there is exactly one subarray, what happens? We just have to find the maximum. Find the maximum. That's it. And find the max element. That's it. We don't have to do anything else. Now here is where the trick comes for this question. If my k is between 1 and n, so let's say I have this array, right? So let's say I'm iterating over this array. Fine. What happens? What happens when I'm iterating through this array? I can have, like, let's say I'm starting at index I. Then my window will be I plus k minus 1. This will be my last element, right? Now, whenever I start from I, every element in the middle, every element which is not a boundary element, will be repeated at least twice, right? When? So let's say my k is 2. So my second element will be present in this window, start like ending at I, and it will also be present in the window starting at I. So it means that my middle elements, non-boundary elements, will always be present in at least two windows or two subarrays. So they can never be my answer, right? Only my boundary elements can be the answer. But when can boundary elements be the answer? If the global frequency is 1. So boundary element can be my missing, almost missing number if global frequency is 1. So if, and we have to return the max of it. So this is the entire trick of this question. Now let's get started. So in here, instead of having a hash map, we see my nums of I will be in between 0 to 50. So let's have an array called frequency and give it a size of 51. Why 51? So that my last integer index is 50. Now, calculate the frequency. So the way we are going to calculate the frequency is using for each loop. We'll iterate through the nums array. And for every number, we are going to store its frequency of num and increment. So this is how we store the frequency. Next, we're going to iterate through the array and iterating through the array is and let's store the value of n. So int n is equal to nums dot length. Why I have done this, I'll tell you. So I is less than n, I plus plus. In here, we are navigating via nums array. So if what can be my cases? If my k is equal to n, then I just have to find the maximum element, right? Then in that case, let's have a variable called max, initialize it to -1. Why not integer dot minimum? Why not minimum integer? Because it says 0 to 50, so we can do that, but let's initialize it to -1. And in the end, we're just going to return max. So if my k is n, what do I have to do? I have to find the max of um, k maximum variable and what? Nums of I, correct? Because why nums of I? Because there is only one subarray possible. Fine. If not, then I have to first check if the frequency is 1. So how do I check if the frequency is 1? We'll get that through frequency array. Frequency of what? Nums of I. If this is equal to 1, then we are going to check for the other cases. And any of, so this will be clubbed into one function. So if my frequency of nums of I is 1, then if my k is 1, then this is true. Or if my k is between 1 and 1 and n, what happens? If we only need to check if it's a boundary element, right? So how do we check for a boundary element? If I is 0 or if I is equal to n minus 1. So if these cases hold true, we are going to check for the maximum variable and then run this code, submitting this. So coming to the time and space complexity, see our time complexity is big O of n, where n is the length of nums array. Why big O of n? We are iterating for the first time. So this takes big O of n complexity for frequency counting. And then this for checking every element and getting the maximum out of the almost missing number. And our space complexity is constant, which is big O of 1. Why constant? Because we have a predefined array of size 51, since the constraint says that the numbers are between 0 and 50. So that's why. So yeah, that was it from my end. Thanks for watching. Bye.